This video is on the objective determine the critical value or values if it's a two-tailed test for a hypothesis test for the difference between two means. And this is with population standard deviations known. Right? So you can be working with z-scores and the normal distribution, right, instead of t-scores or the student's t. And of course, once you've determined the critical values, you can set up or define your rejection regions, right? It says in order to define rejection regions. And this is the second video I'm doing on this objective. So hopefully you've seen the first one, and I'm just going to get right into it. And as I say, most videos, if you want to see more about the topic, click on more instruction, look at their notes, their videos, their examples, and hopefully those help you out. Alright, so here we have Jeremy Remland is a civil engineering student who lives in a large city that has a vast public transportation network. For one of his classes, he's writing a report that evaluates the city's public bus and subway services. Jeremy would like to make the claim in the report that the population mean commute time for city residents who take only the bus to commute to work is different than the population mean commute time for the city residents who take only the subway to commute to work. Alright, so I'm going to write this right now on some paper. Alright, the claim. Alright, the claim. Let's say this is for the bus. Right, so they're telling us that too. That later in the problem, they're saying let mu1 be the population mean commute time for a bus in minutes, for people who take only the bus. So the average commute time for people who take a bus, he's claiming that it's different than, right? So just not equal is different than the average commute time for people who take the subway, right? And that's going to be mu2. Now, another way to state this involving the difference between the two is mu1 minus mu2 is not 0. Right? And then if we were setting up hypotheses, you have a null hypothesis, an alternative hypothesis. This would be the alternative hypothesis, right? That mu1 was not equal to mu2, or that mu1 minus mu2 was not equal to 0, right? Just that these average times, these average commute times for bus travelers and subway travelers are different. And then the null hypothesis would be that they're the same, right? You'd be assuming this in your test, that the average bus commute time and the average subway commute time were no different at all, that they were actually the same value. Their difference is equal to 0. And then from this alternative hypothesis, you can also tell what kind of a test it is, right? This is a parameter not equal to a value. This is a two-tailed test. So when you find critical values, there are going to be two of them, one positive, one negative. There's going to be a right tail rejection region along with a left tail rejection region. Okay. Anyway, back to the problem. So that was the claim, right? So Jeremy uses the results of similar studies that have already been completed to assume that the population standard deviation is 8.07 minutes for bus drivers, people who commute by bus. So that's like sigma 1, right? The population standard deviation for the bus commuters. And 7.14 minutes for commuters who take the subway. So that's like sigma 2. Jeremy conducts a survey using a random sample of city residents who take only the bus and who take only the subway to commute. The results of the survey are given in the table provided, right? Your bus commuter sample, your subway commuter sample. And, like I said, mu1 be the population mean commute time for the bus riders, and mu2 be the population mean commute time for the subway riders. Now, the first question they're asking is, what type of test is this hypothesis test? And I've already mentioned it. It is a two-tailed test. I already wrote it out, right? Because the alternative hypothesis will be that the difference between these average times, these average commute times, is going to not be zero. Right? They're going to be different in some way. All right. Wonderful. And then because it's a two-tailed test, you should be finding two critical values, and that's what they're asking us for the next part. What is or are the critical values of the z-test statistic for this hypothesis test? And they're giving us a significance level here. Alpha is 0.05, right? And use a comma and a space to separate answers as needed. So we're going to, because there are two of these, we're going to separate them by a comma and a space, as you'll see when I type it out later. All right, so back to the paper. So when I go to, so they're giving us alpha here is 0.05, right? The significance level is 5% for this test they want us to perform. So later when we're finding critical values for the test, you're going to be dealing with a standard normal distribution, right? Z-scores, right? The test statistic will be a Z-score. So I'm going to draw a picture here of the standard normal distribution, right? Your axis represents Z-scores. You got a symmetrical bell-shaped curve above that. The Z-score underneath the peak is a Z-score of 0. And what we're looking for, right, because again it's two-tailed, we're looking for two values, one on the right of the mean, one on the left of the mean, so that the area to the right of this critical value and the area to the left of this critical value, they add up to 5%. So each of these areas should be, half of 5%, which is 2.5%. So the area of this right tail rejection region, 2.5%. Same thing over here, the area of this left tail rejection region, 2.5%. So what we're looking for here is, what is the z-score with 2.5% above it? So that's that z with a subscript of 0.025. And its opposite. What's the opposite of that z-score with 2.5% above it? That'll have 2.5% below it. And these I can find from the table they provided. See here, the z-score with 0.025 is a subscript. That's the z-score with 2.5% above it is 1.960. Right? So this value up here, this critical value is 1.960, and this value over here is negative 1.960. Right? And then I would, then if I had my test statistic calculated, I would put it on the number line and see if it falls in one of these rejection regions or not. And then you'd reject or fail to reject the null hypothesis and then make a conclusion. All right? Do you support the claim or not? Does the evidence support the claim or not? But we're not asked about all that. We're just asked to type out the critical values. So I'm going to go from left to right. I'll go negative 1. I'll put the positive one first. 1.960. Comma, space, right? Comma and space, as they said, and then negative 1.960, right? There should be two of them. And those are the critical values, right? The entrances to the rejection regions. And that's all we're asked here, right? That's this whole objective, right, is just determining the critical values for the test. We're not actually doing anything more than this in this objective. You do more steps in later. I have other videos coming from this assignment where you're completing more steps. So hopefully you take a look at those as well. All right. So hopefully watching me do this and looking at the more instruction, reading the answer explanations when they come up. Hopefully all this stuff helps you when you're working on this material on your own. And thank you for watching.